Morning, everybody, and thank you, Jeremy and Francesco, for actually setting this session up. I'm going to be talking about percolation analysis and the deep history of regionality. So I'll just give you a brief recap on percolation. I did give a presentation on percolation analysis at this conference last year in Tübingen. I'm then going to talk a little bit about its application to probing deep history. And then I'm going to conclude with some new work that we've done on percolation analysis called the connection coefficient, and I'll explain that as we go. So percolation analysis is a modern way or a recent way that we've started working with for looking for patterns in spatial arrangements. And this is part of a long tradition. So going back to the 1930s, we've got work that Fox was doing, looking at hill forts in Britain, and he's tried to categorise these in that particular instance on the basis of the type of entrance that they have, a feature. More recently, Hogg in the 1970s was looking at hill forts in Wales and arranging those on the basis of size and so forth. But seeking out patterns, seeking out groups and clusters. And what I've been doing over the past few years is looking at hill forts in Britain as well. So the method that we're using, just as a brief recap, is a continuum method. We are looking at clusters that are formed based on the distance between points. Earlier methods are based on a cellular array or a grid or a matrix. But the continuum method works on precisely the distance between points rather than a grid array. As I presented last year, that was implemented in R, but now we have a solution which has been implemented in GRASS GIS. And one of the drivers for that, and I can talk about that offline in more detail, is to generate some more data, some more outputs, and in particular, connection coefficient. This is very much a progress report, an update, it's work in progress. So looking at the GRASS solution and the case study I'll present in a moment, there are about 3,000 data points spread over the British Isles. And we're stepping through the percolation radius, that is the threshold distance between points of between 0 and 40 kilometers. In 1 kilometer increments. And what that additional information is going to show us is how those clusters form. Very brief recap. This is the data that I'm using. This is the Atlas of Hill Forts project, which Gary Locke has been a key mover and driver for. Fantastic data set. So looking at some metrics here, we have two measures, one of which is the number of clusters for the percolation radius. And this here is the maximum cluster size against radius. And you'll see that this progresses, there are some interesting transition points. So if we step through, this is at 3 kilometers. The coding here is red is the largest, blue the second, and so forth. So just for clarity, we're picking out the top 15 clusters. And you can see that there's a large number of clusters here. Of course, at 0, there are no clusters because they're all individual points. So we step on through 4 kilometers, we can see that cluster is beginning to grow, and we've got some other clusters appearing down here in Wales, and so on. So stepping through 6 kilometers, we're getting interesting things happening here down in Wales. And walking on through, by the time we're getting to 9 kilometers, then some of these clusters are getting quite substantial. And we can carry on through at these various different transition points. And at 34 kilometers, we've got virtually the whole of Britain in 2 clusters. And that next step takes us into it pretty much embraces everything apart from a few islands. So just when we see some of these clusters merging, So we see these formation of some of these bigger clusters. What we're interested in, one of the things that we're interested in is the specific sites that are key in the formation of those. And we want to pick those out and see if we can understand better something about them. I'll come back to that in a minute. If we go to some deep history now, there's two case studies I'm looking at. One of them is the hill forts, and the other one is Domesday Vills in Britain. So looking at some clusters here of hill forts, and this is at a 10-kilometre radius, and these are overlaid on the county boundaries that were defined in the Domesday Survey of 1086. Just as a very brief recap, if you're not aware, Domesday was a survey conducted by William the Conqueror, the last successful conquest of Britain or England. And he conducted a survey which gives you a remarkable snapshot of England in that year. So it's a very particular time. But what we can see is that we've got some quite interesting matches between these clusters of hill forts and the county boundaries, which suggests that what we are seeing is the hill forts have been constructed. There's some sort of spatial integrity there, perhaps reflecting some sort of socio-political entity which has been reflected over 1,000 years later in county boundaries. Another recent study, which was in 2015, is a study done at Oxford on the genetics of modern Britain. I won't go into that too much detail, but this definitely showed up distinct genetic variants. I mean, not huge variants we're talking about, but definite distinct variants in different parts of Britain. And just to highlight that here, we've got Cornwall and Devon, and we've got those clusters forming there. So there's some interesting things going on in deep history, and our clustering mechanism is highlighting those and pointing them out for more investigation. So looking at Domesday Vills, we've got a much bigger data set here, nearly 13,000 points. And because they're much denser, we're looking at a much more fine-grained clustering. So we're going in 0.1 kilometre increments. Nothing much seems to be interesting happened at 2.3. But if we go at 3.2 kilometres, then we're definitely picking out clusters that match into county boundaries. And also, interestingly, what we're seeing is a reflection of early medieval kingdoms there as well. So again, our clustering is picking out stuff for interesting investigation. Now, I mentioned one of the things that we're particularly interested in is the role of individual sites. These are statistical packages. This is statistics. From the statistical point of view, those points are those nodes, those sites are indistinguishable. But of course, from an archaeological point of view, that is very far from the case. We are very interested in those individual sites and what their functions are. So in particular, we're interested in sites around the edge of clusters. Are they marginal or are they key? And how those individual sites link clusters. And the module that we've developed provides additional information for that. And we've developed a connection coefficient that gives a measure of the connectivity of sites as those clusters grow. So just to briefly summarize, two individual points, not particularly interesting. An individual point to a cluster, not particularly interesting. But if we've got two large sites coming together, then the points that link them together then are potentially much more interesting. Now, just some points on that. It's very much a work in progress. It's not a naturally scaling parameter, and we're still working out how best to apply it, but it is generating some interesting results. So if I look at the clusters of hill forts at 10 kilometres, what I've plotted there in those circles are the sites of maximum connectivity, and for the top 15 clusters. So if we just remove the other ones, it's highlighting some sites that we can go and look at and investigate in more detail. And if we close in on that area in the lower part of the Severn Valley, close to the borders of England and Wales, and pick that out, then we've got here plotted on a GIS, we've got 3 clusters at 10 kilometres in red, green and blue. And if we look at the maximum connection coefficient of sites in there, we've got some ranking so that the sites in red, highlighted in red, are the largest. That's the next one down. And then we picked out some of the scaling ones. So if we then step up the percolation radius to join all those clusters together, and if we then strip out and just look at those sites with the maximum connection coefficient, it's a pattern of points, okay? All right, we've got some coastline in there. So, but if we put a topographical overlay in there, a DEM, then it brings the whole thing to life. And what we've got here is a whole set of sites, a lot of which are sitting on the escarpment looking out over the Severn Valley. This is the Cotswolds, and we've got sites up here in parts of Gloucestershire and Herefordshire. But our 2 sites are sitting down in the valley. So if we put rivers on there, again, this begins to look really interesting. One of our key sites is right on the conjunction of the Severn and the Avon rivers. So this is beginning to look as though our parameters picked out something of quite interest there. If we then put on the Domesday County boundaries, quite complicated, reflecting land ownership patterns at the time, we see that this county boundary here actually includes that site. These are in 2 separate counties, and that is 1,000 years ago. If we look at modern county boundaries, we see that that site is still included in a distinct county. Something interesting potentially going on here. So if we zoom in on this particular site in a little bit more detail, we can see that it is lying between the confluence of 2 rivers, which is quite interesting because that county boundary is actually including this peninsula. And if we look at it in the Hillforts Atlas, we zoom in on that, we find that this site is Tobury Hillfort. It's situated extremely close to the River Severn, which is a major navigable thoroughfare in prehistory. But interestingly enough, we've got a motorway going right next to it. And that motorway is actually one of the oldest motorways in Britain. So our connection parameter, it's a statistic, it's picked out a particular site, but it's suggesting that this site is actually something of great interest and of potentially great importance in prehistory. So just in summary, our continuum percolation has great potential for revealing patterns and spatial distribution, which is allowing us to investigate historic and prehistoric groupings and territories, which are enabling us to probe into deep history. And as I said last year, and I'll say it again, it's a tool of great potential in archaeological spatial analysis. So many thanks to the various people who provided those data sets that we've used, and thank you very much indeed.